So you may ask me, why do we do the diagonalization? So if you have a matrix like A11, A12, A13, A21, A22, A23, A31, A32, A33, you can say there are so many entries, right? So why do we do the diagonalization? Because if you write it as a dialog, it's easier because you only have three numbers, but all others are zero. Okay, now how do we find the diagonal matrix? So the method is like this. First, we have a matrix. So in maybe 2 by 2, 3 by 3, or n by n in general. So the step one is you compute f lambda is determinant of a minus lambda I. So this is a characteristic polynomial. After you get this, the second step is set to set this is 0. You will solve lambda 1, lambda 2, lambda 3, and lambda n. So if you get lambda 1 to lambda n, you will, if this matrix is diagonalizable, you can write it in lambda 1, lambda 2, lambda n. If it's diagonalizable. But you may ask me, if not, of course, you cannot write it in this form. So, of course, you can always write it in this form, but it doesn't give us a lot of information. So you may ask me when, and also you can ask me if this is A, this is gamma. You may ask me what's the relations between A and gamma, right? So third step, for each lambda I, we can find the eigenvector alpha I, lambda n. You can find the eigenvector lambda n, and then we put the eigenvector together as a matrix like this. This is alpha 1, this is a column vector, and alpha 2, and alpha n. So we get a n by n matrix. Okay, so after we got this, you may ask me, why do we do this? So the reason is that after we find a P, and finally we have A P inverse is lambda 1, lambda 2, lambda n. So when you are doing the problem, so which part do you have to pay more attention? So if you want to, because after you get a lot of lambda, so you may ask me which one is lambda 1, which one is lambda 2, or which one is lambda n. So which is first and which is last? That's not important. But after you fixed the order, for example, this order is very important for you to write a P with this property. If you put a lambda 1 in the first position, you have to put alpha 1 in the first column. For example, you write lambda 2, lambda 1, lambda 3, and lambda n. If you want your P with this property, you have to, in this case, you have to write P in alpha 2, alpha 1, alpha 3. Sorry, alpha. Is it clear? So it's this kind of, if you change the order of the lambda, the eigenvector, the order of the eigenvalue decided how do you put your eigenvector. Okay, I think that's part is important because a lot of students asked me this question when I told this before. Okay, I think this part is very important, and there is a name like this. We say A is similar to this gamma. If we write this as capital gamma, so today is kind of first you have to know how to solve the equations. I think last time I already talked about this. So talk about the solving the equations. And today the new topic is how do you find the eigenvector? No, how do you find the diagonalizable or diagonal matrix? And how do you find the P? So one more question. So the question is when is a matrix, or when a matrix cannot be diagonalizable? If for n by n matrix you cannot find n eigenvector, means that it cannot be diagonalizable. That's kind of the theorem. Okay, so I think I'm done.